Let's look at our first one, 28 over 63. To simplify this fraction, we just want to divide out common factors. We are going to write each of these terms as a product of primes and divide out those common factors. 28 is a product of 4 and 7, but we know 4 is not a prime number. We can rewrite the 4 as 2 times 2 and then write in the 7. 63 is a product of 9 and 7, but 9 is not a prime number. We can rewrite 9 as 3 times 3 and then we have the 7. So now we have our product of prime numbers and we are ready to divide out common factors. There is a 7 in the numerator and a 7 in the denominator. We can factor those out. There is nothing else in common to both the numerator and denominator, so we can multiply our factors out, and this gives us 4 over 9. Since we use this prime factorization, we can be assured that 4/9 is in simplified form. Let's look at part B. We have 12x minus 6 over 14x minus 7. Again, we want to reduce the fraction as we did in this previous example. Remember, we cannot divide out sums or differences, we can only divide out products. Notice that this rational expression has differences, so we need to rewrite these as products using factoring. The numerator has two terms, 12x and 6. Notice that these terms have a GCF of 6. We can rewrite this as 6 times 2x minus 1. Let's look at our denominator. It's the same thing. We have 14x minus 7. The GCF is 7. We multiply 7 times 2x minus 1. Now that we have products, we can divide out those common factors. We can divide out this 2x minus 1 with this one here. So what do we have left? Simply the fraction 6/7. Fractions that contain variables are sometimes called fractional algebraic expressions. There is a special restriction for all fractions, including fractional algebraic expressions. The denominator of a fraction cannot be 0. For example, in the expression 3x plus 2 over x plus 4, the denominator cannot be 0. If you set the denominator x plus 4 equal to 0 and solve for x, you'll see that x equals negative 4. Therefore, the value of x cannot be negative 4. We have x to the third power plus 11x squared plus 30x over 3x to the third power plus 17x squared minus 6x. Notice that both are trinomials. So remember, in order to reduce these rational expressions, we need to have products. This means we need to rewrite each of these as factors. We look at our numerator and look for the GCF. The terms don't have any numerical common factors, but each term contains an x, so the GCF is x. We write the GCF x, then inside the parentheses, we have an x squared plus 11x plus 30. Let's look at our denominator. Notice that all three terms also contain x, so that would be our GCF. Take it out. We have 3x to the second power plus 17x minus 6. Now we need to check our fraction to see if it's fully factored. In fact, we can factor these two trinomials. In our numerator, we have a leading coefficient of 1. We know that the only two possibilities here are x and x to give us the x squared. What two numbers have a product of 30 and sum to 11? We can try 6 and 5. 6 times 5 is 30. 6 plus 5 is 11. That works out. Now let's look at our denominator. We have a little tougher problem here. The leading coefficient is not 1, it happens to be 3. We can use trial and error to find our factors here. We have to use 3x and x to get the first term of 3x squared. Our middle term is 17, so we need to think about which products of 3 and our last term, 6, will get us close to this number. 6 times 3 will give us an 18, and then when we subtract the 1 here, we would have 17. Now again, let's get the signs correct. We want a positive 17, so we want to make this a positive 18 and negative 1, which gives us the positive 17, and the negative 1 times positive 6 gives us that negative 6, so it all checks out. Now we're going to divide out those common factors. We have x's. Those can be divided out. We also have an x plus 6 in the numerator and denominator. We can divide those out as well. Okay, so what do we have left after we divide out those common factors? We have x plus 5 over 3x minus 1. Now we should not be tempted to divide out those x's there. Our answer here has sums, not products, and we can only divide out when we have products of terms. Let's simplify some other rational expressions. Let's look at part B. We need to simplify 2x minus 5 over 5 minus 2x. Notice that there are a couple of things going on here. For one, both the signs are the same. Secondly, the terms are the same, but they're written in reversed order. So, how are we going to reduce a fraction like this? They're not perfect squares, so we can't use the difference of perfect squares. There is no greatest common factor, so we can't divide out anything. Let's see what happens if we take the denominator, 5 minus 2x, and factor out a negative 1. We can write our negative 1 and then the parentheses. We need to think about what times negative 1 is a positive 5. Well, negative 1 times negative 5 is positive 5. Now, what can we multiply by negative 1 to get negative 2x? It is a positive 2x. Let's check the signs to make sure. Negative times negative is a positive 5. Negative times a positive gives us a negative 2x. We have negative 5 plus 2x. Now remember, addition is commutative, so we can rewrite negative 5 plus 2x as 2x minus 5. Let's rewrite our original fraction with the equivalent expression, negative 1 times 2x minus 5. Notice that both the numerator and the denominator match perfectly. They only differ by this negative 1. So we can divide those out, and we have 1 over negative 1. And 1 over negative 1 is simply negative 1. This problem is an example of a special case when simplifying rational expressions. There are some things we can look for that will help save time in the future. First, check to make sure that the entries are the same, just in reversed order. Next, check that those signs are both negative. So for instance, if we had a minus b over b minus a, we know that would be negative 1. If we had 3m minus 2n over 2n minus 3m, we would know that is negative 1.